Oh, yes, yes. All right, so let's get started. So, are you aware of uh, the all certifications in CCNA? So, basic there are certifications, global certifications, which you have to write online, right? So, in CCNA, it has been divided into two part: ICND1 and ICND2.
Okay.
But the combined is 200125. That's the exam code. So, if you are planning to book the exam, you have to book the exam based on this code, which is the global code for the Cisco.
So that will be CCNA certification, right? Switching and routing.
That will be CCNA certification, true.
And it is 2 exams.
There are 2 exams, ICND1 and ICND2. CCNA is a combined exam of both.
I see. Okay.
Right. The validity of this exam will be 3 years. In 3 years, we have to go for another exam, maybe professional level, CCNP, any of the module, or you have to write the cross technology like security, CCNA security, or
Yeah. So
CCNA.
once this is done, we will set a path, because I am more interested in security, but we'll see how I am able to grasp this topic.
All right, all right. So that's what. And the exam fees nowadays, it is $325 plus
Okay.
18% tax.
Right.
All right, so we are going to cover the routing and switching CCNA. In the CCNA routing and switching, we will start with the network because it is all about the network. And now routing and switching, it is the core of the network. It actually talks how to set up the network, how to implement the different variations, different protocols in the networking devices, and how to make them end-to-end communicate. Moreover, how to utilize the resources, networking resources. Right, so in CCNA, it's a Cisco Certified Network Association, which is again the associated level program, basic level program, which covers actually the small industry network issues, implementation, design. Well, so the question will be, what is network? Because it's all, as I told you, it is all about the network, right? So what is network? So the network is basically the connection between the two end devices, two nodes, right? It could be two computers. It could be computer and printer. It could be computer and the other networking devices, right? So why do we use network is so that we should be able to, by sitting in one place, we should be able to share the file, we should be able to share the database, access the database, we should be able to give the print command by sitting in one place, and so it makes our life very easy in terms of communicating, right? That's all about the network. Now, in order to do that, there are so many bits and pieces in this which are involved, which we have to go through. We'll go through the each and every all networking devices, and we'll see how it works actually. Right? Well, so in this, there are two types of network basically. The first is wired network, and the second is wireless network.
Okay.
The wired network, where we need the physical connectivity, physical connection to connect multiple devices, right? And the data will be converted into the bits 0 and 1, right? And the second is the wireless, where we do not need any physical connectivity. The data will be transmitted from one device to another device through the wireless signals. Right? So which means there are two types of LAN now. One is the local area network and one is wireless local area network.
Okay.
So this course will focus on the CCNA network, which is your wired network.
Right.
All right. So when we talk about the types of network, as you see the slide, there are types of different network like LAN, CAN, MAN, WAN, and these are basically based on your requirement. Though this routing and switching will completely kind of focus only about the LAN and WAN, because so LAN is normally used in industry and will be used normally in enterprise companies, and WAN is where your enterprise company gets connected to the service provider or WAN provider. Right? In between, we have campus area network and metropolitan area network as well.
I see.
So the LAN concept, what is this actually? The LAN is local area network. So when we say local area network, which means the connection between the LAN cards. I mean, every device will have a LAN card, right? So in that LAN card, we will have a unique address called MAC address, media access control address, which is also known as hardware address, physical address. This is actually 48 bits long address, right? So now when two PCs, two computers are connected to each other, they will be connected to each other using the LAN port. Now in each LAN port, as I told you, there will be a MAC address. So MAC address is a 48-bit, again, a unique address which provides the identification to the device locally. So basically there are two types of addresses in computer, in networking devices: MAC address and IP address. IP address is a 32-bit logical address which provides unique identification to the device globally. So you might be thinking, why two addresses? MAC and IP, why not one? So it's like the MAC is used within the local area network, within the LAN for communication, and IP is used for the global. Though IP is called as a transportation protocol, which carries the data from one end to other end. So IP is required, must. But when we talk about the LAN, in LAN, to communicate with other machine, we need to have a MAC address. If we don't know the destination MAC address, we won't be able to communicate. Right? So LAN is basically a group of LAN ports. So normally the network within a building, they all will be connected to each other, right? Using the LAN cards, LAN ports. And the cable which we use is Ethernet cable. We will have connector, RJ45 connector, which will get connected to the LAN card. In that LAN card, there is an IC, network interface card, right? I was talking about the MAC address. This 48-bit MAC address will be burnt into that particular NIC card.
So how is LAN card different and the NIC card is different?
No, under LAN card itself is, under LAN card, there will be a NIC.
Okay.
And under in NIC, there will be a 48-bit MAC address. It's kind of sealed.
Okay.
All right. So
is it like LAN card is like a physical slot and then the NIC card goes inside, something like that?
So LAN card is, yes, a physical slot. In that LAN card, we will have the portion. That portion name is NIC. So yes, NIC is attached to the LAN card as an inbuilt to the LAN card.
Okay.
Right. All right. So next, the another type of network is CAN, campus area network, which is again. So if suppose we have a couple of buildings in the same location, right, and one LAN card, one connection is going in your one building, one LAN connection is there in one building, and the one LAN connection is in another building. Now, to communicate between them, you have two options. Either you contact service provider and get the connection from your one building A, right, and also from building B, and communicate each other. But this will be very expensive, as you have to pay charges to the service providers, isn't it? Now, since these both the buildings are close to each other, adjacent, so what we can have the, the switch. I mean, all computers will be connected to the switch. We will talk about the switch and all, why, how switch comes in picture. So all devices will be connected in building through a switch, and the same type of network will be built in the building as well. Now we will take the connection from one switch in building A to the switch in building B. So it is like kind of extending your, LAN connection itself, expanding your LAN local area network to the different building as well. Right? So that kind of network actually is campus area network. It is, yes, it is used in terms of with the companies where they have, multiple campuses in particular, location. So they use this kind of network instead of paying charge to the service provider. Clear?
Yeah.
All right. The next is Metropolitan Area Network, which is again larger than LAN, right? But smaller than WAN, larger than CAN as well. So which means we have two now locations, and we have branch offices in the same city, but the two different branches, two different locations. So in that case, again, since that location is not that big and we have to have the secure communication, I don't want to rely on the service providers for our communication. And this will be definitely costly if you lie down the line from, from one location to other location, right? So you have to dig the earth and then lie the line from one location to the location, which will be again costly. Right, but this is kind of one-time investment, right? So this is hardly used, this kind of connection. In fact, for the different locations, we use WAN connections, or we use service providers to get connected and to communicate each other.
So how does the service provider connect, like the WAN? They also have to dig and put the cables all the way, right, around the city or something.
Yes, since now that's what they are charging for, because they have already established network everywhere. Right. So now, since they have the availability, they can provide the connection for you to have communication between the two different sites, two different branches, and that's why you are charging them.
Yeah, but it's also a wired connection, right?
Yes.
Okay.
And the last is wide area network, which is, yes, widely used. This is basically the expanded to the geographically, which is the collection of lands, which is collection of CAN and MAN. So where your enterprise gets connected to the service provider. Now one service provider will get connected to the other service provider. And that is how all service providers, all WAN providers, they will be connected to each other and making the wide area network, WAN connection. You can refer the, connecting one country to the other country.
Right.
Right. So these are the types of network. As I already spoke about the wireless local area network, that is for the Wi-Fi. Now, in order to get connected to the Wi-Fi, we normally we use access point. So all wireless and wireless devices will get connected to the access point, and then access point will get connected to the controller. Right. Next is storage area network.
So do they ask questions on the VLAN?
No, there won't be any question from the wireless.
Okay.
Next is storage area network. So this is storage area network connects servers to data storage devices. Data storage devices means let's say my company is acting as a service provider to provide this storage to the end devices publicly, maybe for example Google Drive, right? So this is virtually you have the only application, but these storage media will be somewhere in the data center, isn't it? I mean, the big, very big storage devices, very big hard disk and all, it will be available somewhere,
Right.
which is again provided to the public,
Mm.
right? So this kind of actually storage devices, when it we connect, that will be called storage area network. Now, to communicate with those storage devices, we have to have the different protocol. Different protocols will be used. Different type of connections will be there, right? Pretty much same, but little different than the normal LAN.
Mm.
All right. So after this, we have the topology. Topology is nothing but how your devices are connected. There are two types of topology. One is physical topology, and one is logical topology. So physical topology is how your devices are connected physically, and logical topology is something the way the devices are communicating. That becomes logical topology,
So
right?
this they talk about the bus, right?
Correct.
What exactly the bus is?
That's what. So in this actually, in bus and like physical topology, we have like bus, the liner bus topology, right? This was the actually first topology introduced, and the bus topology is where all the devices are connected to each other using the single wire,
I see.
right? So if I have four computers, for example, they will be connected to each other using the single wire.
Okay.
There will be T connectors, which will be connecting the computers together. There will
Okay.
be terminator points so that the signal cannot cross the boundary,
Hmm.
right?
Okay.
Using the advantage of this kind of topology is the cost wise, it is cost effective, as in you don't have to spend so much to particular build a network,
Right.
right? But as well as easy to set up the network. But disadvantages wise, based on your criticality of the business, there will be different disadvantages as well. So for
Mm.
example, since single wire connects your all machines, so it
Mm.
becomes no single point of failure,
Right.
right? In case if any from anywhere, if the termination happens, the connection gets broken, then the entire network will be down.
Mm.
The second disadvantage will be, so if you talk about now the three-way of transmission, how the devices communicate to each other, right? So three-way of transmission, where we have simplex, where we have half duplex, where we have full duplex, right? So that is how the devices actually communicate to each other. There will be nodes, there will be equipments which will be communicating to each other based on these actually the methods. Now the simplex is where the device will have only capability to send the data or receive the data.
Which one? Which is that?
Simplex.
Okay. It's a. Is this the same? It's not on this page, right? It's on a different page.
No,
Or
it
you?
won't be there. I believe this is kind of little. 1 second. It won't be there. I believe. No, it won't be there.
Mhm. Okay.
So, as I told you, simplex is nothing but the device either can send the data or receive the data.
Okay.
So those kind of devices are called simplex device. So, for
Mm.
example, your keyboard. So keyboard has got the sending, capability.
Mm.
For example, monitor has got the receiving capability.
Mm.
So now whatever you are typing in keyboard, which means you are giving input, so and that whatever you're typing, that will be displayed in the monitor, So monitor has got receiving capability, keyboard has got descending capability. But if you want to send vice and versa, it won't work. The second is half duplex. In half duplex, descending and receiving capability, both the capabilities will be there, but at a time one. For example, your walkie-talkie. And so whatever you're speaking, you have to press the switch, right? So if you have pressed the switch, you won't be able to listen anything.
Right.
So to hear anything, you have to release the switch, right? So that kind of devices are half duplex. And full duplex is like, mobile. I mean, you can send and receive the data at the same time, like mobile.
Okay.
So when we talk about the bus topology, it works basically in half duplex, right? So which means if 4 devices are connected to the single wire, and if one device is sending the data, so rest 3 devices will be idle. They cannot send the data now because that transmission media, that cable is already busy, that there is already data in that cable. But if any of the machine sends the data, it will result to the collision. Right. And that is where the collision happens. Now, what is collision? Collision is where the two machines send data together at the same time using same transmission media, the same direction, and the data will get collided. That situation is known as a collision. None of the device will receive the data because it is lost in transit. It is lost in between. Right. And the third disadvantage is how you communicate, how your devices communicate. Like we have, there are 3 types of communication, like unicast, multicast, and broadcast, which is pretty much, simple and basic to understand. So unicast is basically when the device communicates with particular one device, right? That situation, that communication becomes actually unicast. Multicast is when the device communicates with the multiple devices. Not all, maybe you have hundreds of machine in your network, but not with all devices, but few of them. That becomes multicast. If I want to announce something, right? So I will announce, and that will be delivered to the all machine. That will be the broadcast. So broadcast is one to all communication. So unicast basically one to one communication, multicast one to many communication, and broadcast one to all. Now in bus topology, it is actually one to all communication, means broadcast. It does all the time broadcast. So there is no integrity, there is no confidentiality in this. So for example, if PC A sends data to PC B, right, and other computers are also connected in the network, so that data will be received by rest of the computers, isn't it? So security wise, it is not that much secure, because at the end, all the devices are connected to the single transmission media, right? So fifth disadvantage is shared bandwidth. When we say shared bandwidth, which means if the total capacity of that link is, the single wire is, let's say 10 MB, and if two machines are communicating to each other and utilizing 6 MB, so 4 MB is left for the rest of the machines to communicate. So there might be a situation where you don't have even bandwidth available to communicate, right? Yeah. So these are the disadvantages in the bus topology.
Okay.
Now, the bus topology, if you might be thinking, I mean, since it is full duplex, since it is half duplex, So if one device is sending, so none of the devices will be send the data, and there is no mechanism, as when we haven't discussed about any mechanism where they should detect the signals and all. So in that case, any device will send and the collision will happen and data will be lost. There is no mechanism of here the acknowledgement and all,
But
right?
if there is a half duplex, at
Mm-hmm.
a given time, only one will send the data. So how come there will be a collision?
All right, it only one. So for example, we both are connected to the single wire. Now you are sending data, right? And I am receiving the data. But other devices which are connected to the same media, they don't know where the communication is happening, isn't it?
Right.
So they will also try to send the data. Hello, C, I have some data for you. I have some file for you. And they will process. And the moment they process, the collision will happen.
I see.
Now that time it was a very big issue, and that is why IEEE they introduced one method called CSMA-CD, which is carrier sense multiple access collision detection. Right. So I'm talking about little history of the network and all. That is why it is not there in this document. But I'll try to add all the documents, whatever we discuss and whatever we're going to discuss further, in particular this document. So in this case, all right. So they introduced CSMA CD, in the Ethernet environment, and what this method is that whenever the collision happens, right, there will be a jam signal sent to every machine on particular that broadcast in that particular network, saying that there is a collision, stop sending data. So all machine on that particular network will stop sending data and wait for the interval. Since now this is carrier sense multiple access, means after implementing this method, before sending the data, you have to sense the link. You have to sense the carrier, whether the data is there in the carrier or not. If the data is there, you have to wait. But if the data is not there, if you think that the carrier is free, you can send the data, you can process the data. So this somehow has given the relax and avoided the collisions. But again, because of the other disadvantages like broadcast and half duplex and all, it was not that much enough to make your network available 24/7 for the business, right? So they introduced another topology which is called star topology. Now in star topology we use actually a central device.
So I'm just gonna break you here. Sorry about that. So thinking about exam, how do they ask questions on all these? Do they ask questions on all this topology or no?
No. This topology and all, it is not there, so they won't be asking any question.
Just for the foundation, just to understand.
Correct.
Okay.
So I'll anyways let you know the topics from there. They will be asking questions, so I'll just keep on posting.
Okay.
Alex, in star topology, what happens? We use a centralized device. It could be now. So when we say centralized device, the role of those centralized devices are to expand locally the network. I have 2 computers, I have 3 computers. How will you connect 3 computers together? So, okay, I will connect LAN card, I will connect LAN, Ethernet cable using RJ45 and connect it to the centralized device. So there will be a centralized device. Now it could be hub or it could be switch, right? So we'll talk about the hub. Initially, the switch wasn't developed. So it is like they introduced only hub, right? In hub, when we use hub as a decentralized device, it eliminates one disadvantage of bus topology is single point of failure. Now this is not single point of failure because the different connections are going to the different computers, right? So all computers will be communicating to each other because they are all connected to the centralized device, which is called hub.
So how is the hub and the switch different? Because it sounds like the same thing.
True. All right. So now in hub, they introduced hub, right? But inside of the hub, what they did is they in the internal components are still connected to each other. Means inside of that hub, even the single wire is connected to the different all ports. For example, I have in hub, I have some 12 ports, 12 LAN ports, right? Now all 12 LAN ports are connected to a single wire. So apart from this single point of failure, inside, since they all are connected to each other using the single wire, they are still making the hub duplex, right? So, I mean, if someone asks what is hub, so basically hub is used to, as I told you, hub is used to provide, expand local area network, and it works in layer one, physical layer device. So hub is a physical layer device. It works in layer one. Right? And yes, it supports hub duplex, means whatever we have discussed in the bus topology, everything will be same in case of hub as well. Which means if any computer communicates with other computer, right, other computers won't be able to communicate. So at a time, there will be one who will be sending signal, or there will be one who will be receiving the signal. Another, it is broadcast. It does broadcast all the time because again, internally or inside of that hub, sorry, inside of hub, again they make the same, bus topology itself. So the data sent by one computer will be received by all computers, right? Which is again broadcast. So hub works in broadcast environment. Shared bandwidth, it does share the bandwidth, right? So as I told you, apart from one disadvantage, which is the single point of failure, yes, but this hub actually eliminates that single point of failure, but it has got still all disadvantages as an hub duplex, broadcast, shared bandwidth, right? So that is why they introduced the switch. Now switches are basically, again, switch also actually expands local area network. The purpose of the switch is also same, but now switch is intelligent device, right? Which works in the layer 2 data link layer. We'll talk about this layer, so Osi model and all. But switch works in the data link layer, and moreover, to forward the packet, to forward the data, it uses the MAC address. It uses the address called MAC address, source MAC address, and destination MAC address.
I see.
And switch works on the full duplex instead of half duplex. So which means there is no point of collision because the device can send and receive both together.
So why switch is on the layer 2 and not layer 1? Because that is also physical piece of device, right?
It is a physical piece of device, but it forwards, the forwarding mechanism is based on the MAC address. And MAC address is allocated in the data link layer.
I think MAC address falls in physical also, right?
No, MAC address won't be there in the physical.
I see.
Physical, where we have only 0 and 1 bits and bytes.
Okay.
Right. Apart from that, now instead of only doing broadcast, switch actually supports unicast, it supports multicast, it supports broadcast. So whenever it is required, it will do broadcast, but switch will, if switch has got all the information, if switch has learned all the information about the MAC addresses and all, it will always do unicast, which will reduce the traffic because broadcast is really bad for the network. Right. And moreover, switch provides a dedicated bandwidth to the each particular machine because switch is bi-directional communication, where hub was unidirectional communication. Right. So if someone asks what is switch, switch is a layer 2 device which is used to expand local area network, and It forwards the traffic based on the source MAC and destination MAC. It has got its own functionalities, so which we'll discuss later. Switch, it provides the communication based on the unicast, multicast, and broadcast. It supports full duplex, and moreover it provides dedicated bandwidth to the machines, right? Now in local area network, usually we use switch to connect all the devices. So switch is normal. So if you are actually going to design the network, in that case you will from the topology perspective, you will use star topology within the enterprise, and from the hardware perspective you will use switch to connect all the devices. All right, so that's about the switch. Now one thing that we have some machines. All machines are connected to the switch using the LAN ports, Ethernet cable, RJ45 connector, right? As I told you, every machine, every switch has got the hardware addresses like MAC addresses, and every device has got the IP address. Now the communication is happening. Your internal communication, the communication within building, communication within local area network is happening. I am able to send emails. I am able to send data. I am able to share the machine file folder within particular local area network, right? But when it comes to sending the data from network LAN to the WAN, we need router.
So are we still talking about the star topology, or we moved on from the star topology?
No, we're still in the star topology.
Okay, so if you just want for the for expansion of the LAN, we use the switch. But when we want to go from LAN to WAN, we need routers.
We need routers. So ultimately router, because now we need the connection from the service provider. So service provider, they will terminate the connection on the router.
Okay.
And
so switches are needed for, say, if you have a DC to interact on a private network locally within the DC, maybe switches are okay. But when you start going outside, then you need the routers.
Correct. So router basically it connects two different network. It connects LAN and WAN. It connects your enterprise company to the service provider. So router, we'll talk about the router anyways later, right? But let's move to the another topology. Ring topology we do not use. Why I'm more focused in basically the star topology is because nowadays we only use star topology. The other topologies we don't use. In fact, it is not, as I told you, it is not there in the exam as well. So you can also go to this slide, the ring topology. But anyways, the ring topology is basically where the topology is set up in particular circular fashion, and data flows from one direction to the other direction. It is like clockwise or anti-clockwise.
Okay.
Right. Mesh topology basically where we'll have the routers which will be routing the traffic from particular one network to the another network, which will be routing the traffic from particular one network to the closest of the destination by selecting the best path in case if you have multiple paths. Right. So in mesh there are two types of mesh topology: full mesh and partial mesh. Full mesh means all devices, in particular all routers, are connected to each other. So if I have hundreds of routers, they are making full mesh topology, means they all are connected to each other. Right. And partial mesh means the devices are not connected to each other, but the devices are connected to multiple devices, but not all. Right. So that's full mesh and partial mesh. Next is actually tree topology. The tree topology where it includes the multiple star topologies together in the form of actually bus, right? So it will be making a bus topology. In that bus topology, it will be the group of the star topology instead of the single machine. And in star topology, we'll have the group of the machines. So like a tree, right? One tree, and then the branches going to the different actually area. As I told you, I mean, this tree topology and all we don't use much. Only either we will be using LAN or either we'll be using WAN. And in topology, either we will be using star topology, which comes under the local area network, and the mesh topology, which will be coming under the WAN.
Mm-hmm.
All right. So as I already discussed about the switch, two types of switch: unmanaged and managed switch. Right. So unmanaged switches can make any changes. Right. Means if you have any changes which you cannot make, this is fixed. It is like plug and play.
Okay.
Normally we use in home environment managed switches. So you might have taken the internet connection, right, for a couple of users, where you get this kind of switch kind of where we have from 4 ports and 5, 6 ports. You cannot do anything on that. It is everything is fixed in that. You can just plug and play. And the managed switches are where you can make the changes, where you can create the VLANs, where you can separate the local area network, where you can separate the traffic.
Okay.
Right, and as well as you can insert the modules, different modules if it is required.
What is this CSU DSU?
Well, CSU DSU is, there are service providers which they use CSU DSU to terminate their actually connection. So from service provider, only one connection will come to the CSU DSU. Maybe let's say area, right? So from my main branch office or from my main area, I am taking one line, one cable to the CSU DSU, terminating that connection with high capability to CSU DSU. And from CSU DSU, I will connect multiple customers connection.
What is CSU DSU? Like I don't know.
It is channel service unit and data service unit.
Okay. So is it a device or it's just a protocol?
No, it's a device actually. It's a termination point.
Okay.
Right. So which will be normally used by service providers, and they will terminate the connection, the main line to the CSU DSU, where you can actually set up the bandwidth. For example, customer A has subscribed for 1 Mbps, customer B has subscribed for the 2 Mbps. So you can channel, you can channelize this or limit into particular CSU DSU by tuning it for each customer. All right, continue to switch. If you see this slide, I mean, this is what we have discussed, right? Dedicated bandwidth breaks collision domain. All right, so the term here is used basically the collision domain. We already discussed what is collision, right? So when the data gets collided, that becomes collision. But what do you mean by domain? Domain is kind of the boundary here, like broadcast domain, right? So broadcast domain is how long your data, till what end the data goes. So if I am sitting in this building and if I am sending the data, right, if I am communicating, and if my data is going from first floor till the last floor, if my data is going from me to rest of the all machines, that all becomes broadcast domain. Means the overall boundary of the network, how long the data will reach, at what instance, right? So if I have hundreds of machines in my floor or my building, if I am sending anything and if all hundreds of machines are receiving, that becomes actually one broadcast domain, right? So if I want to reach any of the machine, I can send broadcast traffic to reach everyone.
Did you mention G1 broadcast domain, or did I miss here something?
G1, no.
So what is that G1 broadcast domain?
G1 broadcast domain.
Exactly. So what does G1 stand for?
No, I didn't mention that.
Oh, I see.
No problem. All right. And the next is collision domain. Right. So collision domain is basically a small segment of that broadcast domain. So I have again, hundreds of machines, but all hundreds of machines might be in different actually floor, or might be in different, part of the building. Right. So maybe in one segment we have 10 machines, another segment we have 20 machines, like that, and we have some 5-6 segments. All 5-6 segments means a group of machines actually. So all 5-6 segments will be the part of same broadcast domain, right? But collision domain is something where the sender is sending the data and making sure the receivers are paying attention to that data, right? So which means, let's say I am having some meeting in particular one classroom, right, where the other classrooms are also there. Whatever I'm talking here, and the number of people sitting in this classroom are listening to me, they are paying attention to me. But the students, the candidates, the people who all are sitting in other different classrooms, they don't bother about what I'm talking. They are not, in fact, if they are listening, but they won't apply this, because this is specifically to particular this segment, right? So this becomes actually collision domain. So a segment called collision domain.
How it becomes a collision domain?
Well, so for example, if I know the user A and B, right? So there are 3 users, A, B, and C. Now all are connected to me, right? So if user A says that I want to communicate C, since I know where is C is in my segment only, will I send this traffic to the different segment?
No, only within the segment.
Within this segment, because I know the C is in my segment.
Right.
Right. So I won't send this, I won't broadcast now. Instead, I will send that traffic to the C.
Okay.
Right. But if A wants to communicate with D and I don't know where is D, right? It could be anywhere in any of the segments. To reach D, what I will do, I will say, hello all, where is D? There is a communication signal from A. Now this message will be sent to everyone. Whoever is D connected to me will raise hand. Okay, I am D, and I will acknowledge of this request. So D will acknowledge. Right. So to make them communicate, to make A and D communicate, what I had to do this time, I sent a broadcast message.
I understand that, but between what you said, A, B, and C, how it becomes a collision domain? Because it's sending A to B and A to C, they are sending. So how it become a collision domain?
Because switch is known to break the collision domain. Switch is a one broadcast domain. In fact, all devices are connected to the switch. Right. In fact, D is also connected to me. D is also connected to C. Right. But since switch was,
I am missing something in your explanation. So broadcast domain is understood. So collision domain is
okay. Collision domain is
an area where bidirectional communication is possible, and there is a possibility of collision.
No, the collision domain is a term actually, right? I mean, it's a term as in you can consider one collision domain as in one segment.
Okay.
Right. In that segment, so if, as I told you, collision domain, like switch breaks collision domain. So each port of the switch will be one collision domain.
Okay.
right? So which means in that collision domain we might have the group of machines as well. Right? So this is very good feature in switch that breaks it in collision domain. So if switch knows all the addresses of the machine, that okay, I have A, B, C, MAC addresses connected to the particular this port. So and if they come to me to communicate with C, I will not send that signal to the other port. I will still I will keep that signal in particular that port only instead of sending it to everyone.
I see. Ravi, what I would suggest, if you have a diagram, or maybe on some of these things which are sometimes difficult to understand, maybe you can use the window paint sheet, and maybe you can, just basic, you can draw something so it will be easy to understand.
Sure. We'll use that as well.
Okay.
Right. So anyways, we'll keep on discussing this collision domain and broadcast domain. So anyways, broadcast domain you understood, right?
Yeah.
And the collision domain will further talk about. We'll talk about with the examples when we do the practicals as well. We'll talk about the collision domains. All right. These are the terms which we asked, actually terms used in network. Just quickly go through this, like channel service unit, which is used to connect the digital lease lines on the line side. As I told you, the service provider, they will connect, terminate their sessions to the CSU and DSU. The digital service unit used to connect to digital lease lines on the LAN sign. So LAN side means one connection is coming from enterprise, right? So the service provider is connecting it. It's like, let me draw the topology as you said. You see this, all right?
Yeah.
So for example, let's say this is your service provider, right? And from service provider, a main connection is coming to this, and this is your CSU and DSU device. And from, so this connection will be terminated to the CSU, and DSU is where the communication will go to the customer. This is my customer one line, this is my customer second line, customer third line, and customer fourth line, where I will be fine tuning the bandwidth here.
CSU, DSU looks like basically one device.
Correct.
Where one end it is receiving end, and other end it is channelizing and controlling how much bandwidth who will receive.
Correct. Right. Now in this, while making the connection, there are terms like DC and DC, data communication equipment and data terminal equipment. So this connection here, right, it should be actually DC. So for example, this connection over here, the DSU, right? So this connection should be DC, and this connection, maybe this is, let's say, router, the customer router.
Right. So that is DT.
That will be, yes, that will be a DT. Right. Next is DNS, domain name system. So DNS is basically it, resolves the name with the help of name into IP address. DNS is kind of why we started using DNS, because remembering the IP addresses will be very difficult. If I give you 10 IP addresses, you will hardly remember. But if I give you 10 name, you can remember. But devices, they send the based on the IP addresses, not based on the name. So we need a server, we need a mechanism, who can translate that name into IP address and tell to particular those devices that what is the IP address. So for example, if I type www.networkerschamp.com, right, and hit enter, so immediately it will send a DNS query. DNS query will be sent. It will be a broadcast, or it will be unicast if you know the DNS server. That request will go to the DNS server, and DNS server will send a DNS response where it will tell what is the IP address of networkerschamp.com. And then the end machine will process request based on the IP address. Right? So that's That's called DNS. We will have configuration of DNS. We'll see that as well. IP address we have already discussed. 32-bit. MAC address we have already discussed. C is customer edge. Customer edge, as I told you, this particular router will be called as in C, right? And the other router, now this router will be called as in P, because this is provider edge.
Right.
CPE, customer premise equipment, all devices in customer. Let's say this is your now. This connection is going to the LAN, and from to the switch, and from switch we have the other different actually routers connected, switches connected. So all devices will be called as in CP, customer premise equipment. All right, is it clear?
Yeah.
All right. Next is OSI model. We'll talk about the OSI model. Give me 2 minutes break. We'll continue. There is no option to pause here.
There is option to pause.
All right, pause. All right, so next is OSI model. So we'll talk about the OSI model. Right, but before talking about OSI model, let's discuss why was the requirement where OSI model was introduced, right? So as I spoke you earlier as well, the OSI model was organized or was introduced by the ISO. Why? It's because before ISO, there were so many complexity in terms of communicating between two vendors, because one vendor has to follow their own setup of rules, setup of protocols, how they communicate within particular vendor devices. Like for example, IBM, if two IBM computers want to communicate, they can communicate easily because their operating system, their everything is same. All protocols being used, all are same, right, and compatible. But talking about the other vendor like Apple, their device is also communicating within vendor communication. It is happening, right? Because they have their own setup of protocols and all. But now when we talk about the IBM and Apple, they are not compatible to each other. Why? Because their software is something else. They introduce their software in different manner, right? So this issue has become very big, and where ISO has introduced OSI model and announced, what, all vendors, here is the OSI model. We all have to follow this OSI model. Where whatever you manufacture, make sure that it is meeting this OSI model guidelines, right? What it does actually, it actually explains how the data communication happens between two devices. What all are the things required, to communicate, to make a particular data readable and delivered from one particular machine to the other machine, right? So that's what in this OSI model there are 7 layers. But before getting into the OSI, the layers, let's talk about the advantages. Advantages, like it divides big network communication process into smaller and simpler components, which means if I have the everything together, now I have divided this into the layer by layer, right? Where it is helping to for the communication to happen successfully. So if we are breaking the big segment into smaller segments, smaller components, it will be easy to troubleshoot. That's where we have it allows to troubleshoot the issues. Since it has been divided into the layers, at which layer we have the problem, instead of looking at the all layers, I can jump into the particular that layer and check the issue. If I have issue with the network, I will go and check the router. If I have issue with the switch, I'll go and check the data link layer. If I have the issue with the cables, I'll go and check the physical layer, right? So that is how it is. The advantages of the OSI model came. It allows multiple vendors to be work together. So multiple vendor communication is possible because all vendors are following the same path, same protocols, right? Preventing one layer affecting from other layer, because now these layers are separated. If impact in one layer is, the impact won't be in other layer, because both the layers, all the layers are separate. Right? So that's about the advantage of the OSI model.
Right.
Now the OSI model, the seventh layer, which is called the application, the layer actually it actually defines based on the sender and receiver. So if you are at the sender end, then you will start with the application layer. But if you are at the receiver end, you will start with the physical layer, because this physical layer is the bottom layer, application is the top layer.
So if you are at the receiver end, you start at the application, and if you are a sender, you start at the
Correct.
first layer.
Correct. So correct. So if this is the machine, we had this writing pad and it gone bad, so I actually ordered another, so it will be delivered in a couple of days, and then we'll have
You can also use Windows, the Paint, Microsoft Paint.
No, that I can use, but since I'm using Mac, in this actually the drawing is pretty much difficult.
Okay.
So I'll have the writing pad anyways. As I told you, we had all earlier, where it gone actually 40.
Okay.
So if this is the if they are the two machines, and if they are connected to the wire, and this is your sender and that is receiver, right? So now here we will start with the application layer. Now, what is application layer? It is used to provide the user interface. What is this user interface? The user interface is where you can interact with the different applications.
So sender. It starts from application, because you are sending something.
Correct.
Right.
So before sending something, you have to, for example, if you are writing an email.
Right. You need a browser. You need an application.
Correct. You need an application where you interact with the different services. You need a browser where you need a Gmail or any application, Outlook, where you can write the email. Right. So that's what OSI model says. To interact with the different services, you need application. Right. Like operating system, like Internet Explorer. If you want to browse something, and if you don't have Internet Explorer, you cannot access the internet.
Right.
Isn't it? If you don't have operating system in your machine, in your PC, you cannot work. If you don't have application, if you don't have Android in your mobile or iOS in your mobile, you cannot work.
Right.
So to interact, we need the application. Right? All right. So the protocols and we'll talk about later, because these protocols come under the TCP/IP stack, TCP/IP layer. We have another model called TCP/IP model. So we'll talk about these protocols there. But I have included everything together here. But in actually OSI model, there are no protocols. I mean, they haven't actually described the protocols.
Okay.
Right. So all right. So if I have, let's say I want to send some letter to particular destination, I have opened a notepad where I wrote the letter, whatever I had to write. I wrote it. Now the data will go to the presentation layer. From application layer, it will be handed to the presentation layer. So what presentation layer does actually, it makes that data in human readable format. Right. So an example, presenting service like conversion of EBCDI, which is extended binary coded decimal interchange code, right, to the ASCII format, American Standard Code for the information interchange. So it makes basically the data, whatever data you have written, if it is the text, it will make it human readable. If it is any MP3 file, it will make it to the, again, human readable, right, where the human can understand it. So, and also it makes sure that what application has been used, right, at the sender end, the same application should be used at the receiver end to open the data.
Right.
So for example, if you're sending any MP3 file, so it will add the extension of that MP3. So that receiver can understand that I have to use any MP3 extension or media to open this file.
I see.
Right? And it is also presentation layer is also responsible for the coding and decoding, and compression and decompression. If you remember, that zipping, compressing the file and making it very light, that all happens in the presentation layer.
Okay.
Right? Encryption and decryption. So it will also encryption, as in it will for the security purposes. So that instead of sending the data in plain text, it will encrypt the data and then send. So it increases security.
Right.
And at the receiver end, it will decrypt at the presentation layer.
Sender at the sender's end also it will encrypt at presentation, right?
Yes, this is from the sender perspective. So from sender, coding will be happening, compression will be happening, encryption will be happening. At the receiver, decoding will be happening, decompression will be happening, and decryption will be happening.
Okay.
All right. Next is I have to remove this. The next is session layer. So once you open the application, once you wrote the data, once you have decided what you want to exchange, right? It will go to the presentation layer, will make sure the extension and all responsibilities and the data will be handed over to the session layer. Session layer will create this session between the two applications. Session layer will create the session between sender and receiver, between source and destination. So for example, two applications where you must be aware, whenever we click on particular anything, let's say there is a notepad in your desktop, clicking on that notepad, which means you want to open that file, you want to send a signal to the processor to open it.
Okay, so that's the session that opens up.
Correct. So that's the session. Now it's notepad is here. I mean, this PPT is still here. I clicked it, the PPT is open, right? But it is not going anywhere till the time I am again clicking in the cross. Right. So which means the session layer is the background, it is maintaining that session, and it needs actually the user interruption to remove this file. So till the time it will maintain the session. I mean, sometimes what happens, the session gets timeout, right? So session will automatically terminate. Right. So it's session layer, it creates, maintains, and deletes this session. Okay. In upper three layers, nothing will be happening with the data. I mean, the data will remain the same. Only the extensions and the sessions will be created. The all upper three layers are also called PDU, Protocol Data Unit.
Which unit?
The Protocol Data Unit.
PDUs. Okay.
PDU. Right. So on three layers, nothing will be happening. It's like the data will remain the same. When the data is handed over to the transport layer, the first thing what it does.
In the first three layers, application, presentation, and session, the data remains the same, but it does remain the same as an electrical impulse or binary?
It will binary. Binary, it will be same.
So where it is impulse? In the
actually it hasn't been converted into binary yet. I mean, data is still in the machine, right? Data is still not been touched. It is like data has been ready, it is ready, but nothing has been changed with that data. Whatever data you have written, let's say you have some file, right? Or you have written some data in your notepad, so that data is still there.
Okay.
Right, it's still there means nothing change happened with that data.
I see.
Now when that data will be handed over to the transport layer, the first thing it does is segment, because based on the size, now transport layer check what is the overall size of that data. Fine, the size of the data is, let's say, 20,000 kilobits. Right now transport layer will see, okay, am I capable to send the data in one go? No, because in transport layer there is something called MTU, maximum transmission unit, and which is set to the 1500, which
Yeah,
means
so we have VIATAs. I told you we use routers, VIATAs and routers and firewall and other stuff. So lot of times there is a requirement to change the MTUs to 9000, but I will talk about that later. So yeah, I'm
yeah, I got it. Anyways, it might be some tunnel or something. So yes, but maximum in physical, actually, layer, in physical layer, as in the we're talking about OSI physical layer, layer one, the maximum transmission unit is set to the 1500, means which you cannot send above that, right? So
no matter what,
transport,
no matter what.
no matter what, as in, yes, there are, I mean, pros and cons. There are, other solutions that you can do it,
Okay.
but I'm talking about the normal communication.
Okay.
So what it does, actually, it breaks the data into the 1500 segments, 1500 bytes. The segment of E1 segment of will be size of segment will be 1500 bytes, right? So it will now 15,000 bytes, sorry, 1500 bytes divided by 20,000 kilobits. And if you divide, you will get some, number of some 30 segments.
Right.
Right. So which means there are now 30 segments in transport layer to be processed further.
Okay.
Right. And when it actually segments, it will also provide a sequence number to the each segment based on to reassemble it properly. Transport layer, it also provides end-to-end communication, where it adds the source port and destination port number. This actually, end-to-end communication is not where you are communicating with one computer between two computers. In computer, as I told you, there are a lot of services running. Now, which service you want to hit in particular that computer, that is called end-to-end communication. So transport layer makes sure what is the end application, or what is the end service that this user is going to access. So for that, it will use source port and destination port.
Okay.
Right. It also provides the connection oriented data, stream support, reliability, flow control, and multiplexing. So flow control and all that we'll talk about anyways in a moment. But the transport layer is the main layer of the OSI model. It does a lot of things actually. Right. It also corrects the data error. Correction happens with the help of CRC, cyclic redundancy check. We'll talk about that. But when we say flow control, so flow control is something, it prevents sending host one side of connection from flowing. So what does that mean? It means, so if I have data, and let me take the, okay. So if I have this machine and another machine I have here, right? And if they want to send the data, right? So it is like this transport layer will send the data, but it also makes sure so the data should not be discarded at this, in case if the receiver becomes unusable, if receiver becomes unresponsive, right? So data will be stopped immediately. There is something called flow control. There is something called windowing and all, which we'll talk about in next slide, I believe, or we'll talk about in TCP UDP, the TCP protocol. So we'll talk about the three-way handshake, we'll talk about the windowing, we'll talk about the flow control there. But what happens here in flow control, if this sender keeps on sending the data to the receiver, and if receiver is dropping because receiver doesn't have maybe memory, maybe buffer, or receiver is busy receiving the data from other sources, right? So in that case, receiver will actually send a notification to the sender immediately to stop sending data.
When it finds out that it's dropping or it cannot receive, then it will send a notification.
Correct. So immediately receiver will send stop signal, as in the window size. There is something called window size we'll talk about. So window size is 0. So when sender receives window size 0, So sender knows that, okay, I have to stop now. I have to stop sending data.
So what process is this?
That's something called windowing. So we'll talk about windowing. This is something called,
Oh, I thought it was stream support because that's what you talked. Okay.
No, that's something called windowing. So we'll talk about that. Right. Next is after flow control, we have some acknowledgement. Any segments not acknowledged are transmitted, segments are sequenced, right? So acknowledgement, because actually what happens, okay, anyways, here TCP, UDP, here we have. So we'll talk about that now only. What happens when in transport layer, there are two protocols, TCP and UDP.
Okay.
Right. Now TCP is called as in the connection oriented, where UDP is called connectionless. Right. So connection oriented means it creates a session using three-way handshake and then data is transferred.
Okay.
Right. So what happens? I have source and destination. This is source and receiver. And before sending, if this source has got some data to send to the destination, before sending, the TCP, it supports actually three-way handshake. Three-way handshake is, it will send a synchronized packet to the source saying that, you know what, hello destination, I have some requests. I want to create a session between you, because I have some request for you. I have some data for you. In that three-way handshake, it will send synchronized packet. Normally it is called SYN. Synchronized packet, SYN packet 1. Right. So in this SYN packet, it will have its own capability, what is the size of the data, what is my capability and all that will be exchanged. When receiver receives, it will acknowledge with the acknowledgement of this SYN. Okay, I have got your request. Now I too want to acknowledge and plus SYN2. SYN2 means I too want to send I too want to establish a session with you. And this is my capability. Here is my SYN packet 2. And now the receiver will send final acknowledgements. Fine, okay, I have got your SYN. Now I am going to process. I am going to send the data. So that is something called three-way handshake. One way, two way, and three way. Remember, in TCP, if the three-way handshake is not completed, data will not be forwarded. Okay. Some security vulnerabilities where what happens, I am a hacker here. This is a hacker. I will send a SYN packet and will receive the acknowledgement, but I will never send the acknowledgement. This is called actually the half session open.
What is called half system?
Half session open. Right.
Half session.
Half session open. Half session open means the receiver is still waiting for the acknowledgement, final acknowledgement, but I'm not sending acknowledgement. But the session is still open. This session already, because it has almost established.
Right.
Right. So now I can send denial of service attack, man of the middle attack to particular this receiver.
Okay.
Because this session is open. Right.
So instead of sending acknowledgement, now the hacker can attack.
Correct. Now this is the time to attack.
I see. Okay, so if you have a little notepad or something, if you can please put this point, this sync 1, sync 2 acknowledgement, sync acknowledgement plus sync 2, right? So when we are troubleshooting, for example, the router or anything, if we run like a TCP dump or something like that, and I don't know exactly what they run, but one time I saw it showed like SN1, and the other guy was explaining that sync 1 is not happening or acknowledgement is not happening and it's dropping the packet. So maybe when we're doing practical, maybe can we demonstrate and see this and understand the output and everything?
Yes, we can, yes.
Okay, cool. So if you can just put a note, and I'm gonna send, after we finish this, I will send you an email with whatever points I have remembered, I put it on the WordPad and I'll send you.
No worries, no worries. We'll remember everything. Don't worry. We'll not forget anything. So
Okay.
if you wish, I mean, you can send an email. But anyways, it will be recorded as well as I'll keep. I'll make sure.
So you can add this point from your notepad to that WordPad. So you will have an updated thing, and then we can discuss the same piece of paper.
Sure. I'll do that. And this process is called actually the three-way handshake. All right.
Okay.
Once the three-way handshake is done, then this sender will send the first packet. Okay, here is my first packet, packet number 1, right? And then receiver, why it is called connection oriented? Because now receiver will send acknowledgement of each packet. Okay, so here is the acknowledgement of 1, means I received it. Sender will again send the second packet, right? And then receiver will send an acknowledgement. Sender will again send third packet. So that way it will keep on going. Now this is little irritating in terms of getting the acknowledgement in each packet.
Right.
So what they do, they decide the window size. They say, you know what, let's not, send acknowledgement for each actually packet. Let's set up the window size, right? So receiver will say, okay, my window size is, let's say 36,000 bytes, which means you have to send 36,000 bytes to me, right? Once I receive 36,000 bytes, I will send you the acknowledgement, right? So now window size is 36 bytes. This sender will receive window size with the 36 bytes and it will send 36 bytes. Okay, here is the data. Data is streaming. Now when receiver receives 3600 bytes, it will send an acknowledgement, right? But in between, there might be a situation where some of the data got discarded here, dropped. Out of 36, some of the data in between, it got dropped in between, right? So now to acknowledge, receiver will send an acknowledgement immediately saying, I haven't received this sequence number. So
now it's not acknowledging every packet, but it's acknowledging a window size of 36,000 bytes.
Correct. But in case if in between data gets dropped,
okay,
right? So receiver is anyways calculating the checksum and all, right? So based on the checksum, it will send the acknowledgement asking for to resend the sequence number. The same the sequence number which you have sent got discarded in between. You just resend it. So sender will
just one packet which is discarded. It will send only one.
Correct. That is something called TCP retransmission.
Retransmission. Okay. So windowing, and then windowing, if they find a mistake, the receiver finds a mistake, it will send an acknowledgement saying that I have not received this sequence or this packet. So it will the sender will retransmit the particular piece that is dropped.
Correct. Okay. All right. Next is in this only we'll understand the flow control. So in this, so for example, the sender is keep on sending the data, right? Receiver doesn't have no buffer size, right? So receiver at the end will keep on dropping the packets. So instead of dropping the packet, immediately it will say window size 0. So now sender will stop sending data, but when receiver has got another again buffer size available, it will again send the window size with the available buffer. Okay, fine, you send now 1,000 let's say packet, right? So receiver will send a window size of 1,000 and sender will send 1,000 packets again. That's something called flow control.
I am missing something here. Can you repeat this? So who decides how much window size, and who decides that?
Receiver.
The receiver decides what is the window.
Correct. So receiver, because receiver only send the window size 0, right?
But why would it say window size 0 when it received 36,000 bytes before?
No, 36,000. It sent the request that you can send me 36,000 bytes data.
Okay, so that receiver did that, right? Okay, so the receiver selected the window size of 36,000 bytes.
Yes.
Okay, so then why was 0?
Now let's say this receiver doesn't have any buffer size. This
No,
receiver
sender.
is busy. It doesn't have any memory available.
Whose? Receiver or sender?
Receiver.
Okay.
Right. It doesn't have any CPU available, process available.
Okay.
So now receiver will send a window size 0.
Okay, because it cannot process anything at this point.
Correct. So to stop sender sending data, it will send window size 0.
I see. Okay, got it.
So now sender will stop sending data. But later when receiver thinks now I have got the buffer and the memory and all size, the processes have been released, then it will again send the window size and request for the data till the time the session will be established.
Okay.
Right, that is called flow control.
Okay, and the session is continued during this process.
Yes, session is continued. Yes.
Okay.
So in TCP supports windowing, three-way handshake, flow control, connection oriented, but UDP doesn't support any of them. Right. So that's the difference between TCP and UDP. Normally TCP is used for data and UDP is used for video and voice.
Okay.
So whenever we actually send voice and video, they send they use UDP protocol. Correct.
What does it do? It just keeps sending whether you receive or you don't receive, doesn't matter.
Because in voice and video, they are very delay sensitive and all. First of all, they do not need any acknowledgement.
Okay.
Right? Because once data is sent, data is sent. Second, video or voice, there is no point of sending the, retransmitting the data, because once it is lost, it is lost.
I see.
Right? So that is why this voice and video is used for UDP. Yes. All right. Next is network layer. So the network layer is like, the segment will be handed over to the network layer. Network layer.
So this was the transport layer that we finished.
Sorry.
This was the transport layer that we finished, right?
Yes. So from transport layer, the data will be handed over to the network layer. Now network layer. So as we discussed, in transport layer, segmentation happens. In network layer, packet will happen. Sorry. So the segment will be converted into packet, and the IP header will be added to the segment. Right? IP header will be added to the segment. Now in network layer, as I told you, we have IP. So it will add source IP and destination IP. Right? And add it to the particular segment. So network layer is responsible for assigning IP address and subnet mask. It understands packet, means packeting happens in the network layer, and router works in the network layer.
It understands packets only, assign IP address and subnet mask. Okay.
Right. So as soon as it receives the segment from the transport layer, what it will do, it will add the source IP, destination IP, and it will add the IP header. So what I would suggest you, in internet you can search what is IP header, and in IP header there are different fields. So just go to that IP header field, right? And in case if you have any doubt, just ask me. I'll just explain.
Okay.
But just kind of homework for you, IP header.
Okay.
So in fact, IP header, TCP header, and UDP header, and Ethernet header. These are the 4 types of header normally we use in networking. And if we know these headers, it's good for knowledge.
So you said IP header, TCP header, UDP header,
and Ethernet header.
Ethernet
or frame header.
Okay. All right. I'll try to look that up.
All right. So, well, in network layer, as I told you, it assigns the IP address, source IP, and destination IP. When we talk about the packets, there are 2 types of packets used at network layer. One is data packets, and one is the route updated packets. The data packets is nothing but used to transport user data through the internet network. Means whatever, like IP. I told you IP is a transportation protocol. Who carries the data from source to destination? IP, internet protocol, either IPv4 or IPv6. Right. Route update packets.
It says two types of packets.
Packets used at network layer. Data packets. Who will carry the data packet is IP.
Okay.
Right. And the second is route update packets. So route update packets, there will be routing protocols which will be using route updates to send the packet from one router to another router.
Okay, so data packets are carried on by the IP.
By the IP.
And the routing information is carried on by the protocols.
Protocols, correct.
Right. Yeah, I have to repeat. If I repeat, this is like an interactive. Hopefully, I'll remember this.
No problem. No problem. All right. Next is data link layer. So once it is added, the network layer will forward that packet to the data link layer. Now the data link layer, what it does actually, it's a second layer of Osi model, and it is responsible for adding MAC address to the packet and convert packet into frame. So framing happens at the data link layer, where it will add source MAC and destination MAC. Right? So now it has become frame. In this particular layer, there are two sub layers, MAC, as I told you, which it has already added the MAC address. And the second is LLC, logical link control.
So after the IP header, after the IP packets, when it goes to the second layer, it becomes the frame.
It becomes the frame, and MAC address will be added at the sender end.
At the sender end, okay.
Yes. But at the receiver end, this LLC comes in a picture.
Okay.
Because in the receiver end, the data will be received in physical layer. And then it will be received from physical layer, it will be to the data link layer. Now the receiver is required to understand the network layer protocol. So that's where LLC, it uses data link layer, LLC, is used to find out network layer protocol and then encapsulate them. Right. So to identify who is my network layer, right, it uses LLC and send it to the network layer at the receiver end. At sender end, it uses MAC address. At receiver end, it uses LLC.
So, but then when was the, now this is a little confusing. So,
what's the confusion?
Where was the data? Was the data already encapsulated in this process? Not yet.
Not yet. I'm talking from two perspectives.
Until second layer, from the seventh layer application to the second layer, moving down, it is still in the raw form, which is electric impulse, or no?
Correct.
It's in binary, not electric impulse. It is in binary, right?
It is. Nothing has been done yet. It is still there with this machine only. The data is still with the machine.
Okay.
Right.
Okay.
Now, once the MAC address is added, the data will be handed over to the physical layer.
I see.
Now,
so this data is not left the source machine until second layer.
Until physical layer. Now, when it receives to the physical layer, now the physical layer is responsible to convert that frame into bits, 0 and 1.
Okay.
Sometimes the data will be converted into electrical signal.
Right.
Right. But that used to happen in analog. Right. But in digital, nowadays, what happens? Your data will be converted from data frame to the bits.
Okay. So now I got it. I was confused. So nothing has left the machine. The whole layer process is first process, the sender end, completed, reaches the layer 1, and then it is sent out.
Correct. Now the data has been converted into bits, and data is on the way now, on the wire. Right. In physical layer, we have devices like hub, repeaters, cable, modem. These devices, these equipments, nodes work in the physical layer. Right. So that was about the OSI model, and that is how actually it processes the data. Now, if you talk about at the receiver end, receiver will receive the data at the physical layer, 0 and 1. 0 and 1 will be converted to the frame, right? Frame, in frame, in data link layer, it will check who is my network layer protocol. Using that, it will send that data to the network layer.
What does it mean by who is the network layer protocol?
Network layer as an IP.
Okay, so it will find the IP, which IP is responsible.
Correct.
Okay.
So it will send it to network layer. Now network layer will convert that frame into packet. Just opposite now.
Right.
From packet, it will check source IP, destination IP. Is this for me? Yes, I am the destination IP. Right. So it will now, packet will be sent to the transport layer. Now in transport layer, they reassemble, the data will be reassembled based on the sequence number. Right. And will be, once it is reassembled, 1500 bytes will be sent to the session layer. Session layer will, again, it is maintaining the session, creating the session, and will be sent to the presentation layer. Presentation layer will check, okay, what is the extension being used for with that segment? Okay, this is the segment, this is the extension, right? So, and decompressing it, it will decompress it, it will decrypt it, it will decode it, and it will display the information in the application.
Okay.
Right? So that is how this in the complete OSI model works. So it actually, it does nothing, but it explains how the things work, you know, how the the communication between two machines happens. All right. So that's it for today. I will continue tomorrow. We'll talk about the TCP IP model. We have a couple of more models. So we'll talk about TCP IP model and the hierarchy model, and we'll see further. So far, do you have any question? You can just ping me offline, or we can discuss tomorrow before starting the session.
I see. So tomorrow same time, or you want to make it little like 15 minutes early?
Let's make it same time.
I see. Okay.
All right. All right.
I'm gonna send you that email right now. Okay.
Yep.
All right.